Time feels undeniable. It moves across your skin, across your memories, across the sky. You wake up inside it. You grow inside it. Everything you have ever loved has existed within its grip. We divide it into seconds and years as if it were a physical substance flowing past us. We speak about it as something that runs out, something we can waste, something that carries us forward, whether we want it to or not. But what if that movement is not written into reality? At the deepest level of physics, time does not behave the way it feels. The fundamental equations that govern motion and energy do not insist on a preferred direction. Reverse the mathematics, and the laws still function. A collision between particles looks just as valid backward as it does forward. The equations remain silent about which way is correct. That silence should unsettle us. We assume there is a cosmic clock ticking behind the universe, a master rhythm pushing events from past into future, yet no such clock appears in the laws themselves. What we call time may not be a flowing river, but a parameter, a coordinate used to describe change. Still, change is everywhere. Glass shatters, stars burn, people age. Something about reality seems to unfold. The question is whether unfolding is fundamental or merely apparent. We have never questioned time because it feels too obvious. But the moment physics refuses to guarantee its direction, the certainty begins to crack if the universe does not demand a forward arrow. If time does not fundamentally flow, then what exactly is it? Einstein answered that question in a way that shattered intuition. He proposed that time is not a separate river running alongside space. It is woven together with space into a single four-dimensional structure, space-time. In this framework, events are not fleeting occurrences that appear and vanish. They are coordinates embedded in geometry. Your birth is a point in space-time. This moment is a point in space-time. Your last breath is a point in space-time. Nothing in the structure itself privileges one of those points as the present. There is no universal spotlight sweeping across the cosmos declaring, "This is happening now." In fact, relativity shows that different observers moving at different speeds can disagree about which events are simultaneous. What feels like now to you may not be now for someone moving differently elsewhere in the universe. The idea of a single cosmic present collapses. From this perspective, reality resembles something often called the block universe. Imagine the entire history of everything from the first fractions of a second after the Big Bang to the final fading of the last star, existing as a complete structure, not unfolding, not progressing. We experience time as a sequence because we occupy a specific path through this structure, a world line. But the structure itself does not move. It does not update. It does not advance from past into future. It just is. This is where the discomfort deepens. If space-time is a fixed geometric object, then the future is not something that will be created. It is something that already exists within the structure, just as the past does. The distinction between what has happened and what will happen may not be fundamental to reality. It may be tied to perspective. The universe in this view is not becoming, it is complete. And if that is true, then the flowing present, the sharp edge we call now, may not belong to the cosmos at all. It may belong to us. But even if reality is a frozen structure, one question remains. Why does it feel like we are moving through it? If space-time is a fixed structure without a moving present, then something else must explain why the world feels irreversible. Because despite the symmetry in the laws of physics, your life does not feel symmetrical. You remember yesterday. You do not remember tomorrow. A shattered glass does not leap back into your hand. Something about reality prefers one direction. That preference emerges from entropy. Entropy is not merely disorder. It is the measure of how many microscopic arrangements can produce the same visible state. An intact glass corresponds to relatively few molecular configurations. A shattered glass corresponds to unimaginably many. There are vastly more ways for fragments to be scattered than perfectly aligned. The second law of thermodynamics tells us that entropy in a closed system tends to increase, not because the universe forbids decreases, but because increases are overwhelmingly more probable. Low entropy states are rare, high entropy states dominate. Forward time is simply the direction in which entropy rises. This means the arrow of time is not embedded in the equations themselves. It emerges statistically. The laws allow reversibility, but probability makes reversal almost impossible. Yet this explanation carries a deeper implication for entropy to increase. The universe must have started in a remarkably low entropy state, and it did. The early cosmos was extraordinarily smooth and ordered, an unlikely configuration that allowed entropy to grow and structure to form. The arrow of time may not be a fundamental rule. It may be the echo of a special beginning. And if that beginning had been different, the direction we call forward might never have existed at all. If the arrow of time is born from entropy, then it is not eternal. It exists only because the universe began in a state far from equilibrium. There were gradients, differences in energy, density, temperature, and those differences allowed processes to unfold. Stars ignited because fuel was unevenly distributed. Galaxies formed because matter clumped under gravity. Life emerged because chemical imbalances could be exploited. Every heartbeat, every thought, every flame depends on imbalance. But imbalance does not last forever. Entropy continues to rise. Stars will exhaust their nuclear fuel. Galaxies will drift apart as space expands. Black holes, the most enduring structures in the cosmos, will eventually evaporate over unimaginable timescales. What remains is a universe approaching maximum entropy, a state of thermal equilibrium often described as heat death. In that distant future, there will be no usable energy gradients, no engines can run, no stars can burn, no complex structures can maintain themselves. Without differences, nothing meaningful can happen. And without meaningful change, what does time even mean? The arrow we experience depends on motion toward equilibrium. It depends on the universe, not yet being finished. Once equilibrium dominates, there is no preferred direction left to follow. The distinction between past and future dissolves into stillness. Time as we know it is tied to imperfection. It exists because the cosmos is not complete. It flows because the universe is still relaxing from its improbable beginning. Which means the forward movement we take for granted is temporary. Time is not a permanent feature of reality. It is a phase, a condition that exists only while imbalance survives. And when imbalance fades, so does the arrow. Even if entropy explains direction, it does not explain experience because time does not merely point forward in your life. It feels like it moves. It feels like a current carrying you from one moment to the next. Physics describes structure. Thermodynamics explains probability. But neither explains the vivid immediacy of now. That part may belong to the mind. Your brain does not perceive time as a universal dimension. It processes information in sequences. Sensory data arrives, is integrated, compared to memory, and projected into expectation. What you call the present is not an infinitely thin slice of space-time. It is a constructed interval, a small window where perception, memory, and prediction overlap. Memory creates asymmetry. You carry detailed records of past states, encoded in neural patterns. You do not carry equivalent records of future states. That imbalance generates psychological direction. The past feels fixed because it is stored. The future feels open because it is not yet represented. From the standpoint of space-time, however, all events may simply exist as coordinates. Your childhood, this breath, and distant centuries are embedded in geometry. Nothing is moving through that structure. But consciousness moves through information. Like frames of a film, each moment exists within the larger reel. Motion appears only when frames are processed sequentially. The flow is not in the strip itself, it is in the projection. Time's passage may not be a property of the universe. It may be a feature of minds embedded within it. The universe does not anticipate. It does not feel urgency pressing against it. We do. And perhaps that is the final inversion. The cosmos contains structure, causality, and entropy, but it does not contain a ticking present. It does not experience flow. The universe does not know what time is. We are the ones who invented its movement and then learned to fear it.